And Governor, in light of some of the things you were saying about the change in how people are using money, a friend of mine recently told me about an experience she had in Shanghai. She went over there and was in Starbucks. There was a long line, and she was the sole person in that long line that actually paid with cash. So that's where it's going. And Deputy Prime Minister, we are going to talk about some of the things that countries like Estonia are doing, but also what some of the countries in your own neighborhood are doing. And as part of that, we also will focus on sustainability because I think that helps put this in perspective. But there is a lot of hype going on around blockchain, isn't there? I mean, it's amazing. And so today in the Bahamas, this is one of two conferences going on about blockchain. So I think between this conference and the other conference, I'm assuming that not only is every office empty, but there's nobody on any beach here today. So this is all blockchain all the time. So we're going to start out talking about what blockchain is and what it isn't so we can try to level set and get us all on the same page together and try to separate the hype from the reality so that we can help think about collectively a pathway forward. So two things I want to start with. I want to say what blockchain is not. One, blockchain and Bitcoin are not the same thing. So when we're talking about blockchain, we're not necessarily talking about Bitcoin. Yes, there is a relationship, and we'll talk about that relationship, but it's not the same thing. Number two, equally important, there's this frenzy going on the global basis with respect to ICOs, these so-called initial coin offerings. And we will talk about them a little bit later on, but again, blockchain and ICOs are not the same thing. They're related, and an ICO is a way that people are using to finance a lot of blockchain applications, but it's not the same thing. So what is blockchain? When we're talking about it, I think it's important to start with a definition because there isn't really a universal definition. So let me try. But in the most simple or lay terms, blockchain is really a spreadsheet. It's a sequential record-keeping process that allows users on a peer-to-peer basis to create and maintain data. So it's a new way at the end of the day to think about how we manage data, how we manage information, how we collect that information, how we make that information and data available to people. So the way to think about it is let's start with kind of where the world came from. Let's look at this podium and assume this is a computer server. So in the old-fashioned world, or not the world not so long ago, especially in the 1973 world, when people were going from paper to computers, the way that data got aggregated was that somebody had a central server. And all that data had to somehow be input into that central server, and there was somebody responsible for maintaining that server, that central database. So there was somebody that had to run it, had to figure out who could get access to it, who couldn't, had to make sure the data going into it was the right data, and had to make sure that once the data was in there, it was maintained correctly. And we know how well that works, by the way. If you look at the recent example of Equifax in the United States, what percentage of the American population had their data hacked? I think it was 60% of all Americans lost information about their Social Security, about their driver's license, about credit cards, all because that central database was not properly maintained and it was hacked. Now, the world evolved beyond that to go to a decentralized data management system. So the example might be each bank having its own server and maintaining its own data. Now, the problem with that world is that if you're doing transactions and every bank that's involved in a transaction is maintaining its own separate database, number one, they have to figure out a way to communicate with each other. But the real problem is that that data is getting entered into every separate database separately and by different people in different financial institutions. And there is a high probability of there being mismatches in that data. It often doesn't reconcile. And so not only do you have problems with different databases not being able to communicate with each other, but they also often have data that is wrong. So what's the solution? What's the next generation? Well, that's where blockchain comes in. The concept of blockchain is a distributed ledger technology. And so what does that mean? Let's forget now that this podium is a server, and let's look at every one of you in the room as being what in blockchain terminology people try to call a node, or just simply a computer. So let's pretend that every one of you is a computer, and I have a piece of data, whatever that data is, and I can somehow instantaneously and magically transmit that piece of data to every one of you at the same time. So every one of you has the identical piece of data. There's no need for a central server. There's no need for servers to talk to each other. There is simply this entire universe of data that's out there that is the same, that everybody has access to, and all you need at the end of the day is a computer. So in the distributed ledger technology or blockchain world, all these network users or nodes or computers, whatever you want to call them, have real-time and full access to data that's recorded in this distributed database. And that means that to the extent you want to set it up this way, there's no central authority that's managing the control or access to that database. Now, that's a great concept, but the first question is, well, how the hell can that possibly work? If there's nobody in charge, there's no central database, there's nobody controlling and managing, how could this possibly work? Well, that's where the magic of blockchain technology comes in. So even though everybody, every database, every node has access to the data, and everybody that you want to give access to that data to has the ability to see that data, it doesn't mean that everybody can go in and manipulate, change, and play with that data. In fact, one of the key innovations in blockchain technology is the way data records are managed through an interlinking process, which is why it's called blockchain. So every entry in this public database is in effect a block of data or a block of transactions or a block of information that has a unique identifier. And each block of transactions or data or information is linked with the preceding piece of data that was put on that distributed ledger. In other words, every block of transactions or every block of data is linked to the previous piece of data that in computer speak sometimes is called a child of the previous block. So in creating this single chain or link between one piece of data, the next piece of data, the next piece of data, which is why it's called blockchain. So how is this accomplished? I mean, it's almost like a bizarre concept. So how does it work? Well, and by the way, I should just stop and say, you people are listening to a lawyer talk to you about technology, so take it with a grain of salt. But that said, I will tell you at least how I, as a non-tech person, think it works. So blockchain technology, in order for it to work, uses cryptographic tools. That means that the digital nature of the ledger that is underlying blockchains, in order for them to be tied together, it has to be accomplished through a computational logic and a programming process. So users or the people that design these blockchains set up algorithms and rules that determine how a piece of data gets added to this blockchain or this distributed ledger. So each block, each piece of data has a unique identifier. And that is used, by the way, then to create the unique identifier for the next piece of data. So every time a data goes up to the blockchain, it has a cryptographic unique identifier. And in order to put a new piece of data on the blockchain that will itself have a unique cryptographic identifier, it has to be linked to or tied to the previous identifier. And so without knowing the previous identifier, it is impossible to add new data to that chain. And this is accomplished through a mathematical process. And the only exception really to that is the so-called genesis block. In other words, the very, very first piece of data. So the way to think about it is, let's say that I am Joel Inc. and I want to issue, shares. And I'm going to sell my first share to Rumi, and I'm going to record that transfer on the blockchain database. That's the genesis block. That's the first piece of data. But now, if you want to sell your share to Bob, In order to do that and record it on the blockchain, that transaction has to reflect back to the prior transaction. If you are not able to connect your transaction to the prior transaction in a cryptographic mathematical way, there is no way for you to record that transaction on the database, which means that, among other things, that is the way the blockchain attempts to prevent fraud and things like manipulation and double spending and so on by creating that cryptographic process. So that, and this is where I will tell you that I'm not going to go beyond because it'll sound like gibberish, but it's a combination of public and private keys that are used to create the cryptography necessary to make the data in a form that can go up to the blockchain. The process is a peer-to-peer basis. In other words, there is no central server, no central computer. So because each computer is storing an identical copy of the data, that means that data can be moved around without having to go through some central authority or central computer. And so the outcome is immediately shared by every computer that's being given access to the particular blockchain. Adding new data, then how does that work? Even though it's a cryptographic process, how does it work? Because if all of you are a computer node and you have access to it, what's to stop anybody from putting any piece of data up there that they want? Well, this is where the blockchain cryptographic technology comes into play. In order to add a new piece of data to your ledger, it requires a consensus. Now, there are different ways to achieve what's called consensus, but consensus means that if somebody wants to propose a new piece of data, so you want to put on the blockchain that you're selling your security in Joel Inc. to Bob, and you send out to the universe of all these nodes, hey, I'm selling my security, please record that on the blockchain. It doesn't happen instantaneously. First, it goes out to the world, and there has to be a process by which people prove the validity of that piece of data or that transaction you want to put up there. And so when people talk about achieving consensus, this is what they mean. So it requires solving through a mathematical problem a proof of work, a proof that this piece of data is exactly the next piece of data. And so by creating a mathematical process by which people have to solve a problem which takes the encrypted identifier of the previous piece of data, mathematically that has to be matched to the encrypted identifier of the next piece of data. And only if they match can that new piece of data go up on the blockchain. And so when somebody's proposing that a new piece of data go up on the blockchain, what's happening is that proposed data is going out to computers all over the world. Then you've got anybody that wants to can start to run a mathematical model to try to prove that that is the right piece of data. Because anybody can say, hey, no, that's my security, I bought it or I sold it. But the only way that you can actually mathematically prove that is if you have access to the prior piece of data and you can prove through a cryptographic algorithm that they match each other. So there are computers all over the world that are running very complicated mathematical problems, and the first one to solve it and verify that they've got the correct solution gets rewarded through the market, depending on the type of blockchain we're using, and I'll talk about that some more in a second. But in a very simple term, that's how the data gets out there, and that's how it gets proved, and once it is proved and gets added to this distributed ledger, it is the next piece of data or information on this blockchain, the next link, so to speak, in the blockchain. And by the way, once it's on the blockchain, one of the beauties of how this all works, because of the cryptographic processes involved, is that that information is immutable. I mean, that record can't be changed or altered. Now, I know there's a lot of stuff in the press about hacking and so on, and we will talk about that, but until we get to the world of quantum computing, the general consensus is that that information on the blockchain, once it's there, is immutable, can't be changed, it can't be tampered with, it can't be altered, and the computational algorithms that are used to get that data up on the blockchain make it impossible, once that data is there, for somebody to try to tamper and change it. So that in a very, very big picture way, is what people talk about when we're talking about blockchains. It is a distributed ledger, a new way to manage data and to store data and to give people access to data. So how is it possible that this could somehow revolutionize the world? Because right now, I mean, this is almost like, back in the Wild West United States, where you had people going around the country, selling their snake oil, saying that they could cure anything imaginable under the sun. And I don't think, since I've been involved in this space, there is a single idea or application that somebody hasn't said, the blockchain can solve and fix this. So how is it that a distributed data system somehow solves all the world's problems? Well, let's drill down a little bit deeper, and maybe we can start to figure out how we separate the hype from reality. So there are different blockchain types, and I think that's first and foremost an important thing to recognize. There are both what we call public and open blockchains, which means that, in effect, anybody in the world, as long as they have a computer, can access and see whatever data has been put on that blockchain. So blockchains can be public or private. Either the blockchain is open to the world or it's not open to the world. But also, blockchains can be what are called permissionless or permissioned. It's a variation. In other words, a blockchain can be open, but there may be criteria that's established as to who is able to see that information. In other words, you can have an open blockchain with respect to healthcare data, but it may require permission to access it, so it may be that first you have to establish you're a doctor or you're the patient, but once you do, it's open. Or you can have a closed blockchain that's permissioned, where it truly is intended to be used within a small infrastructure, like blockchains that may be created within certain financial service applications, where you are not putting that information on every computer in the world and then just restricting who can see it. You're only putting that information on a certain subset of computers. So not only is it a permission blockchain, but it's closed from the sense that it's a smaller universe of multiple data sets that you create access to. So let's talk about then, if we've got this notion of open and closed blockchain, permission or permissionless, what are some of the key traits? Because if we look at some of the key traits of blockchain and blockchain technology, that allows us to start thinking about why people think there's so many different applications that you can use them for. So I'm gonna list a number of them in no particular order, but one, and maybe one of the things people talk about the most, is privacy. Because blockchains don't, unless you want it to, blockchains don't store any personal information. And so the private-public encryption process that's used to authenticate users who have access to a blockchain and the data that they're putting up on the blockchain does not have to actually disclose any personal information to the extent you don't want it to. So that means that I can put up data about myself that may allow me to identify who I am in engaging in financial transactions, but anybody that gets to the blockchain and looks at it can see a encrypted representation of me, but they have no way of getting to whatever data I don't want the world to see. So that's the second concept, this concept of pseudo-anonymity. So nodes and users don't need to provide or know the names or personal details to be part of a network. Each transaction and its associated value, in other words, whatever type of data is going up on the blockchain, is visible to anyone that has access to the system. Each node or user in the blockchain, though, has its own unique alphanumeric address that identifies it. And users, though, can choose beyond that to remain anonymous to the extent that they want to. And so it allows you to create a proof of identity to others when you're sharing data or you want to engage in a transaction, but at the same time doesn't require that you disclose more information than you want or need to disclose. All right? The next point, integrity, which I already talked about a little bit. So again, there are two ways that the blockchain, in theory, creates a new way to maintain data with integrity that would prevent the type of tampering that we've seen in existing data systems. First, it's virtually impossible, as I said, to change or falsify blockchain links, the so-called immutability of the blockchain. But second, there's user integrity as well. In other words, the metadata about transactions undertaken by a node are recorded on the blockchain, and they're linked to the user undertaking them. But users can't fool the network to try to complete an invalid transaction because of the algorithm and cryptography that's used to put up new data. And so once a transaction is entered in the database and accounts are updated, those records can't be altered because they're linked to every transaction record that came before them, all the way back to the so-called Genesis block. And so the algorithms that are used allow you to continue to add data and confirm that it's the correct data, but you can't drill down beyond that, again, unless you design your blockchain to do that in the first place. And so probably one of the most important things that people talk about, and this is where I think all the potential disruption, especially in financial services, comes to play, is the concept that this is a distributed trust system, or what some people call a trustless system. In other words, the blockchain, and if there's one thing you remember today, I think really this is it, the blockchain bypasses the need for a trusted central authority. Because of the way you can put data on a blockchain, access that data, you don't need somebody in the middle managing it that you have to go through. You don't need to know who the person is on the other side of a transaction you're exchanging data with. You don't need to know that there's a central bank or somebody else, for better or worse, in the middle managing that process. And so trust becomes spread throughout the network. In other words, the distributed ledger itself becomes the process by which trust exists and by which parties can interact with each other and access or share data without needing to know the identity of the other side or without needing somebody in the middle to verify who the players are. So at the same time that you've got this anonymity and you've got this trustless system, it's almost bizarre because at the same time you've got transparency that goes way beyond what we have in existing types of data management. Because again, since all blocks and information that is on a blockchain is available to all the nodes or computers to the extent you have an open and permissionless blockchain, that data and information is there in real time. So you can't hide the data, you can't redact the data, it's there in real time. So think about that. You don't have to wait for an administrator that's using carbon paper copies to file something, and 3 months later, maybe you can get access to it. That data is there instantaneously, no matter where you are in the world. And even though it's transparent, it's still secure because you've got this cryptographic tool and the public and private keys that protect the data. So it's an amazing concept of trustless, transparent, and yet secure at the same time. So when you start to put all those together, you can maybe start to see why people get so excited when they're talking about blockchain. And then the last thing, and I think this is important when you're talking about a smaller nation like the Bahamas, is that much of the blockchain is so-called open source. In other words, the software that's required to run blockchains and various applications that are built using blockchain technology is freely available to everybody, including the cryptographic tools. And so what this means is that users, as long as they have adequate capacity, can help and enhance and refine blockchain technologies and can help build blockchain technology, can help catch bugs in blockchain technology, and they can facilitate the spread of blockchain technology and innovation, which means that you don't have to be a nation the size of China to be able to take advantage of blockchain, because in effect, blockchain virtually gives you access to people all over the world to help you build your blockchain applications. So you can be here in the Bahamas and rely on developers in Siberia that may have an expertise you need that you can match together for the purposes of a specific project through blockchain technology because of the open source nature of much of the software that underlies it. Now, that all sounds pretty cool to the extent that, you're going, what the hell is he talking about? But assuming if you're with me so far, are you with me so far? Yeah. Okay, cool. So it's not all rosy. There are limitations. And I think that In order to put this in perspective, and again to start to separate the reality from the hype, I think it's equally important, and I want to talk about the limitations as well. So there are some. One is scalability. Right now, under a lot of existing blockchain technology, there is a limit to how many new blocks of information or transactions you can add to the blockchain. In the so-called Bitcoin blockchain, right now you can only add a new block of transactions about every 10 minutes. And so there's a scalability issue. And again, all of the things that I'm talking about are limitations are people all over the world trying to work on and solve. And I think a lot of these limitations will be addressed and solved. But as of today, one of the fundamental limits of blockchain technology is it takes a long time to add new data to the blockchain. And so there's a low volume of transactions can be processed per second, and until we get there to be able to push that up, especially in the world of financial services, there is a fundamental limitation as to how much you can use it, because financial service transactions, require the ability to push through a lot of transactions every minute. So we're not there yet. Second, block size, the actual amount of data that can be recorded on each block on the chain is presently limited. And again, it depends on the particular blockchain technology being used. And once again, there are players out there trying to change that, but right now, there is a limit on the amount of data, and if you can only put so much data, that limits what type of data you can put up, how you can use that data, how sophisticated that data can be, and the extent to which that data can actually be utilized as part of processing transactions that are going to be flowing through the blockchain. Third, and this is important, is the high cost right now of making blockchains work. I mentioned that in the process by which a new piece of data is added to the blockchain, it gets sent out to the world, and anybody that wants to, using a computer, can run mathematical tests to try to validate whether that next piece of data is the actual correct data that should go up in the blockchain. The people that perform this function are, the colloquial is miners. So people that have computers that want to engage in trying to solve these mathematical problems, the so-called miners, have to use sophisticated and expensive computer hardware to run proofs of work, to try to solve the algorithms. And so as a result, there's only a limited number of people that have access to blockchain data that are actually doing this. And one of the problems of doing this is that there's a huge environmental impact. The amount of energy that is required to run these mathematical programs is astounding. No, I mean, we take using computers for granted, but the amount of computer power and thus the amount of energy required to solve these problems is beyond belief. This data is way out of date, and I'm sorry I don't have anything more recent, but somebody calculated that in the beginning of 2017, so the beginning of last year, that just the Bitcoin blockchain, the amount of electricity that was required to solve a mathematical problem to put the next piece of data on the Bitcoin blockchain was comparable to the amount of energy used by 280,000 US households per year. So one of the results of that for now is that mining, the process of proving these mathematical proofs, is becoming more centralized with a small number of nodes controlling a large share of that mining market. So the top 5 companies alone control right now over 50% of the market. In other words, there are some companies that were formed that build these giant computer farms, typically in jurisdictions where the energy cost is lower, which is why China is one of the biggest players. So you've got huge computer farms in China where these computers are working to solve mathematical problems to be able to prove the next piece of data that goes up on the blockchain is the correct data. Now, why would they do that? Well, this is the other piece of the puzzle. There is an economic reward in the way many blockchains work to do that. If you are the computer or the person or entity that solves the mathematical problem to verify the next piece of data that goes on the blockchain is the correct piece of data, you're rewarded. In the Bitcoin blockchain, when you solve that mathematical problem and say, yes, this is the next piece of data that should go up in the Bitcoin blockchain, the software system generates additional Bitcoin and it's given to you. So if you look at the value of Bitcoin and how much it's gone up, you can see that if you're solving these mathematical problems and getting rewarded every time you prove that the next piece of data going up is the correct one, that can quickly add up to a lot of money. There's a lot of value in that. And so if you build big computer farms and are running a lot of computers and you start to solve a lot of the data solutions as far as what goes on the blockchain, you start to earn a lot of Bitcoins and you can get wealthy pretty quickly as long as the price of Bitcoin stays relatively to where it is today. So again, like everything else, there are a lot of folks out there working on alternative ways to prove the validity of data that goes on the blockchain that is designed to create alternative reward systems that are designed to use different types of processes that have lower computing power, lower energy use, but we're not there yet. So right now, that is a real limitation. And then lastly, there's just the old-fashioned limitations caused by things like bandwidth. If you're going to be active in the blockchain space, you've got to have internet bandwidth. Although remind me if we don't, I want to come back and talk about the way some developing countries have bypassed that issue altogether, which I think is kind of an interesting, cool model. Then lastly, there's a usability limitation. Blockchain technology requires secure management of the public and private keys. The way that you access the data. So there's the cryptographic process generates public keys that are available to everybody, but in order to access blockchain data, everybody has to have a unique private key. And so when we hear a lot about hacking right now going on in the world of blockchain, it's not the data on the blockchain that's being hacked. What's usually happening when we talk about hacking are people take this private key, which is the only way that they can access their data and information on the blockchain, and they put it somewhere on a computer or on a cloud server, and then somebody steals it. So a lot of the hacking going on is not the blockchain itself being hacked, it's people losing their private keys, which allows then other people to steal their information, to steal their transaction data, to steal whatever cryptocurrency they're holding in a virtual account. So those problems, real world problems, especially when you're trying to push blockchain out to the masses, is either we have to come up with a different way or we're going to have to do a heck of a lot of education in telling people how to use and protect private keys if we want to really allow blockchain to be implemented at the individual consumer levels. But let me give you, so we've talked about some of the positives of blockchain. We've talked about some of the limitations. Let me give you in no particular random order. I want to talk about some of the uses, just so you can get a sense. And again, there's no magic to the order of talking about this, but financial services, probably fintech or financial service applications is the fastest moving area in all the blockchain. So many of these projects that are going on in the blockchain space actually are really aimed at what we call the unbanked portion of the world. So in a lot of developing countries, particularly in Africa, people are looking at different types of blockchain-based initiatives to allow people to engage in payments and transfers through the blockchain, which means that you don't have to have a world where everybody has access to banks and where everybody has access to bank accounts, and you can have a world where anybody that has access to the internet can start to engage in payment activities through blockchain applications by creating a unique identifier for themselves without having to go through a bank and without having to pay the fees of a bank. So think about that in parts of the world that are underbanked, how we change the global economy just by adding all these additional billions of people to the global economy. That alone can completely revolutionize many things on a global economic basis. So related concept of remittances. Anytime you're looking at a smaller nation that has expats working in another place like the United States, remittances are a big deal because that's a way a lot of economies get money flowing back into their economy. So Remittances there are a lot of blockchain applications looking at ways we can change the world of remittances. So blockchain-based financial services that help people create mobile cash transfers with no fees, by the way. And again, without going through traditional banking structures. So using blockchain technology, because you can create this unique identifier for somebody and allow them to transfer through the blockchain a remittance back to somebody else in a home country. It's already a booming market. Energy, a huge challenge in a lot of emerging market countries. So a rapidly developing sector in blockchain is peer-to-peer energy trading. I don't mean companies, I mean individuals that offer opportunities for people to access renewable energy and to trade it and to come up with a way to manage all the way down at the most local level how you source, use, and manage energy and trade it with each other. So sometimes people call this swarm electrification, but it allows, for example, solar producers to sell solar energy to their neighbor. You put solar equipment on your roof, and all of a sudden, anytime you have excess capacity, through the blockchain, you can make that available to somebody else in your neighborhood. Think of that on an individual level. Supply chain in things like agriculture. Agricultural supply chains is a huge sector where people think blockchain has a lot of potential. So leveraging blockchain technology, not only managing payments or creating automated kiosks to evaluate produce, but to also negotiate price, transfer price. But if you can take agriculture, and especially when you're combining it with nano or micro technology, where you can tag the pieces or things in the supply chain, you can now allow individuals to monetize what they're doing. You can allow the management of the agricultural supply chain. You can use it to eliminate potential medical problems that break out when you have tainted agricultural goods. And so it allows you to completely turn on its head how we get food from the ground all the way to people. And there are, so right now, there are systems that are being experimented on in the Dominican Republic and in Colombia, where we're looking at ways to track the goods from their source to the end consumer that is allowing people to directly interact with the supplying of their local communities, even at the neighborhood level. It's just remarkable. Land registry in a lot of parts of the world. Just trying to identify who owns land and figuring out a way to say, that's my property, that's my land, has been a huge problem. So you've got a lot of countries around the world, like in this region, Ghana, that are testing blockchain solutions that enable blockchain-related land registry, which allow people to search, manage, and verify the property is theirs, and that gives them access to land documents. And then once you do that, by the way, and now creates the way for people to obtain financing to buy land and to buy houses in a way that a lot of people simply didn't have access to. So now you have the ability to identify land as your land, but there are related blockchain applications that are coming up that are allowing lenders to go online through the blockchain and directly connect to these people and lend to them without having to go through, again, a traditional banking structure. Identity. This is huge, especially with respect to a lot of government initiatives in places like Estonia. Taking blockchain applications and using them to create identity for financial issues, for displaced people, for voting, for rights to retirement benefits, to maintain your health data and your health profile. So using blockchains and the ability to create a digital identification for people. There are all kinds of countries around the world that are experimenting with different ways to create new blockchain-related digital identity for their citizens. So this is happening both on the public side and the private side, but allowing people to register their profile up on a blockchain, and then through that being able to interact with all kinds of players in the private and public sector for all kinds of goods and services. Fund tracking.
The ability to better manage and utilize the deployment of funds. And one of our panelists coming up later, Fenny Wang, will talk about the business she's involved in where they are using blockchain to work with governments and NGOs to improve the flow and transparency of funds and services going to underdeveloped markets. So creating a new efficient way to better utilize money that comes in from third-party or non-governmental sources and combining that with the private sector to create more efficient ways to fund various projects. All right, so I would be remiss if I didn't end on these various ways that people are looking at blockchain without talking about what central banks are doing or what they're trying to do. And I think that, you know, in tying after what the two of you talked about in your introductory remarks, when we start talking about a country digitizing its currency, I think it's important to keep in mind that there are two different things that people are talking about right now. And one may not be better than the other, one may not be correct or incorrect, but it's just two different ways that people are talking about how do we take blockchain now and maybe apply it at a country level to digitize our economy. So first, keep in mind that when we're talking about central banks and money, you know, there's really a taxonomy of four key elements or properties. You've got an issuer of the currency, the central bank, or somebody else. There's second, the form of what that currency looks like. Is it electronic or is it the old-fashioned physical, you know, currency that you keep in your pocket? Third, is it a universal or limited type of currency? And lastly, you know, how is it transferred? Is it a centralized or decentralized transfer mechanism? And so the reason why I lay out those four elements is because right now, when various countries around the world are looking at ways that they can create a centralized blockchain digital currency, they're looking at really two different things. I mean, in both cases, they're looking at a peer-to-peer blockchain-related network that somehow it creates the means to create a digitalized currency that's backed by a central bank or central government. But there are two different ways that people or countries are looking at this. One is on the consumer side. In other words, a widely available consumer-facing payment instrument that's targeted at retail transactions and that everybody in the country. In other words, taking the concept of we're going to get rid of cash, we're going to go to a digital or electronic currency like credit cards, but then we're going to go to the final step of the blockchain solution, which is allowing people to create this digital currency trading and usage on a peer-to-peer basis where it doesn't all have to go through a central bank or central authority, where you still control the supply, but in effect you've created an actual replication of your existing currency, but it is now all virtual in a blockchain universe. So that is one thing that various countries are looking at, and I will say that to date there have been a lot of challenges in making that work, and I don't think there has been a solution that a particular country has found yet, because that involves having to incorporate a lot of monetary and control policies while at the same time still allowing things to be done on a decentralized peer-to-peer basis. But the other aspect of the way various countries are looking at creating a digitized or blockchain-related currency is in the context of a more restricted process of a digital settlement system for wholesale payment applications. I think that second one, in effect, where you're creating an alternative form of allowing institutions, financial institutions, to settle and transact among themselves without having to go through a central bank, is a little bit easier first step to implement. We're seeing a lot of examples both in the private sector and on the government side of implicating these types of institutional transfers and settlements using blockchain. And so if I had to guess, that we are likely to see more rapid progress initially on the wholesale side than we are on the retail or consumer side, because the wholesale side allows you to experiment and see how the system works. and make sure that that's viable before you open it up to a consumer side, which is going to require more education, making sure that people have the technology to access the blockchain, and making sure that it's scalable to the size you would need at a true retail level. But in any event, it's going to happen. The only, I think, real question is the timing. So let me leave you then with a couple of concluding remarks for this part. One, I think that there are some interesting aspects to what's happening in blockchain that are especially relevant for countries like this one that are smaller. And maybe you look into this going, do we have the resources to make this work? And so one of the things that blockchain is doing is allowing, in effect, a leapfrog effect for developing economies. And the best way to look at this is to maybe compare it by analogy to what happened in the last decade or so in a lot of African countries, where they, in effect, created a leapfrogging effect by ignoring the old-fashioned infrastructure of trying to build telephone lines all over their countries. You know, African countries had a problem. People didn't have access to communication. They didn't have access to the internet. They didn't have access to landline telephones. And so the solution was, well, why spend billions of dollars to try to build old-fashioned landlines? Let's just create, you know, a cell phone, wireless environment. So in effect, cell phone usage and cell phone technology in parts of Africa are way ahead of the United States, for example, because they didn't have to deal with the legacy system. But the benefit of something like that was that as long as, you know, you can get something like this into the hands of your population, now you start to create the means by which people can access the blockchain. And so if you think about this, and it doesn't have to be the most fancy phone, it doesn't have to be the complicated phone, it just has to be a phone that has access to cell phone towers somewhere. And once you've got this now, you've got the ability to start putting blockchain applications in the hands of individuals in your country. And so if you start to think about it that way, it creates the ability to start to do a leapfrogging type of effect with respect to a smaller nation without having to build, you know, spend billions of dollars to build the old-fashioned type of infrastructure that we used to look at when we thought about internet technology in the 70s and 80s. So that means that we all of a sudden give people at the individual level in countries the ability to bypass the old-fashioned formal economy, because we give them the ability to engage in record-keeping systems and to access those systems, and therefore financial systems directly as long as they have a phone. And we allow them at the same time to get comfortable with this new technology because, again, it's this trusted system where they don't have to give up information about themselves that, you know, that they don't want to. And so when you start to worry about adaptation at the individual level, one of the great things about this is you can say to people, we're not asking for all your personal information. You don't have to give up all your personal information. Here's a way for you to start to engage in commerce without having to pay expensive bank fees, for example, and without having to identify who you are. So go out and do it. So what's the bottom line? What's the bottom line? I think there are four main requirements to really push blockchain forward in a country. One is infrastructure. So, you know, again, a blockchain ecosystem requires some type of infrastructure. Primarily, it's, you know, from the telecommunication side. I don't think that this is the type of place that's going to all of a sudden become one of the primary mining jurisdictions. So that's not where the focus is, but as long as there is appropriate infrastructure on the telecommunication side, again, the ability to use a phone, that becomes one of the foundation pillars for moving forward with blockchain technology. But that also requires a couple of other things, and part of that is the infrastructure, the need and ability to educate the population about what this is all about, how they can use it, how they can access the whole private key aspect of it. And so to push it forward, there have got to be policies and procedures in place which not only promote the necessary telecommunication infrastructure, but the necessary education that goes along with it in order to assure adaptation. So second, is capacity development. Countries need human capacity to develop and deploy new technologies. So it's not just the technological capacity, but it's the ability to manage, again, to train and educate people, to manage and use private keys, to help them understand what's necessary to move blockchain forward. Now, the one positive thing about that, as I mentioned before, is that the peer-to-peer and open source nature of blockchain technology allows you to utilize resources well beyond the borders of your own country. So yes, you need to have the human capacity within a nation to help push it forward, but blockchain allows you to virtually pull in people from all over the planet to help you do that. And a lot of it is done through ways where you're actually not spending your own dollars to even do it. So there are blockchain structures that not only give you access to developers around the world, but they can be incentivized through other types of commercial means that doesn't require government direct expenditures to make it happen. So that's one of the nice aspects of blockchain. Third, though, and importantly, and this is obviously critical role for government play, is policy and regulation. So the capacity of governments at all levels is necessary to develop, implement, and enforce the policies that need to surround the use of blockchain. And particularly right now, the most critical aspect of that is the ability to be agile and flexible. Because blockchain and blockchain technology are changing so fast, it's hard for regulators to keep up. It's hard for them to barely understand what the heck is going on in the blockchain space, let alone keep up with appropriate regulation. But the best a country can do is to be flexible and do their best to try to understand and look at and analyze where the technology is going and have a balance between not too light of regulation, but not too heavy of regulation in order to promote innovation, promote the technology, but to make sure that people are being protected at the same time. It's a hard task, but that's probably the most important thing from the government perspective that can be done if you really want to push blockchain forward. And then the last are institutions. This would be what I would call rules of the game that allow people to undertake activities within a given institutional context. So it's the right governance mechanisms, it's the right policies, it's the right training, it's bringing it all together into an ecosystem that facilitates not from the top down use of blockchain, but facilitates and promotes from the bottom up the use of blockchain.